So let's say the person A, who is going at 2 kilometers per hour, is at this point, and then the front of the train just meets this person. Now, in this 90-second time that it takes and crosses, this person is still walking, so maybe they are at this point. I'm exaggerating, of course. And then once the train has passed, the back of the train is at this point. So that's kind of the visual of the scenario. So we can figure out how much distance this person has walked in 90 seconds. So it's 2 kilometers an hour. I'll convert everything into meters and seconds. An hour is 60 times 60 seconds. And I multiply the rate by 90, and that will give me the distance traveled in seconds, in meters. So that's 30, 3, 20, and then this becomes 50. So this person has walked, I should say, 50 meters. And so if we look at just the front of the train, the total distance that it has covered in that same 90-second period is the length of its body, and let me call that L, plus that 50 meter. So its average speed is L plus 50, the distance that it has covered over time. And again, this is in meter per second. And we'll get a similar scenario for the second person who's going at 4 kilometers per hour. So I need to do the same thing. How much distance has that person traveled? Actually, let me write it as 60 times 60. We'll try to reduce this in 100 seconds. So this is in meters. So that goes out, and this is 36. So 4 goes into 36 9 times. So 1,000 over 9 meters. And that means the average speed of the train is L plus, because it will again cover the body of the train, plus the distance that the second person who is walking at 4 kilometers an hour has traveled in that time. And then we divide that by 100 seconds. Now these two speeds have to be the same, and that's the condition that will give us the length of the body of that train. So I'll leave it in that form. You'll see that 0 drops out. Then I'll cross multiply. 10 times L plus 50 is equal to 9 times L plus 1,000 over 9. So that becomes 10L plus 500. 9L plus 1,000, because that 9 and 9 conveniently cancels out. That's 500. So length of the train is 500 meters. We need to figure out the time it takes the train to cross this electric post, which is really the length of its body, meaning if this is the front of the train, once it reaches the point where the back of the train is here, it would have traveled the length L. So I need to figure out the time. Now I can figure out the rate of this train. I can use L as 500 and plug that in here. So it would be 550 over 90 meter per second, and the time it will take would be the length of its body, which is 500 meters, divided by its rate. And note, this is in meters, this is in meter per second, so the answer will come out in seconds. And it's just about simplifying this. And you'll note the question says nearest to. So that goes, I'll divide by 5. That's 100. So the answer is 900 over 11. 11 times 8 is 88, and around 11 times 2 is 22, close. So the answer is 82, which is choice B. Now I want to comment about this question. I've done enough of these train and different questions, but this is a new one for me. And I think that's what the purpose of this test is, that you're testing familiar ideas, but the presentation is new. So no matter how much you practice, you will always get something that's very different from what you've seen before. And that is, of course, always hard to do this under time and pressure. And that's why the test can be difficult. But this is what you're training for, is new scenarios applying the existing basics. So I would recommend you to practice as different questions as you can, so you're prepared for these new variations. So to summarize, the answer is B.